And this will be the last one for the day, right? So you guys can breathe easy. Hydroquinone. This is one of the things that's used. It's got a lot of uses in industry and that, but it's used to develop photographs with. All right. And here's the data that we are given. 37. Okay. It says that hydroquinone here is an organic compound commonly used. It has a molar mass of, so it has a molecular weight of 110.1 grams per mole. Now what does that mean? That means when I add this whole entire thing up, it must weigh what? 110. Now does this weigh 110? No, how much does it weigh? 12 plus 16 is what? No, that can't be right. 12 plus 16 is 20. Plus 2 more is 21, 22. So this right here is obviously not hydroquinone, right? I done told you it was formaldehyde. It's obviously not hydroquinone. Here's what hydroquinone's got. It's got a 65.45% carbon, percent hydrogen, and a 29.09% oxygen. And it wants to know the molecular formula of hydroquinone. Okay. Well, the first thing you do is you find out the empirical formula, right? Nothing's changed. Okay, so here's what we got going on. 12 grams of carbon comes from the periodic table. 1 gram of hydrogen, 16 grams of oxygen. I am converting to the number of moles, right? Because I've changed my percentage, I've converted the number of moles. Okay, what's my next step here? Divide by the smallest number, right? This is divided by 1.818, which is 1. Okay, so 2.99, can I call it 3? 3. So here's what I got. Here is my empirical formula, final answer, the one that I've gotten through the experiment. All right, is going to be C3H3O. Now, is this also my molecular formula? In other words, if I add all this charade together, will I get 110? Well, go ahead, type it in. Type it in for me, somebody, and tell me what you're going to get. How much? It'll be more than 36. 55 is what you're getting? All right, so Sandy says she's getting 55 grams per mole. She's telling me that this is a perfect empirical formula, but it ain't my molecular formula. Now, what would I have to do to make this my molecular formula? Double it. Now remember, these are ratios. Now does that mean you can double the carbon but not double everything else? Oh no. If you decide to double, just like Bella suggested, that's a fine idea. And you can make that C6H6O2. Or, what if she wanted to triple it? Could you do that? Sure you could. There ain't nothing wrong with that. C, 3 times 3 is 9, H9O3. You do whatever you want, but you'd better do it what? Across the board. Now, if she tripled it, she would overkill, right? Because what are we shooting for? 110? So add all this up. 6 times 12 plus 6 plus 32 equals. All right. So this right here is its molecular formula. It tells the chemist how it's connected. Now what does hydroquinone look like? Somebody, count for me the carbons here. How many do you see? Count for me the hydrogen. Okay, there's 4 blue ones. Count for me the oxygen. There we go. Hydroquinone. All right, or dihydroxy benzene. Some people call that dihydroxybenzene. Yes?
How did you add up to 110?
Oh, periodic table. Here's what I did, Bonnie.
Weight, right?
Yes, ma'am. 6 times 12 plus another 6 times 1 plus 16 times 2. All right. Do you see that? Or, if you'd like thinking like she did, just 55 times 2 is 110. You know what I mean? Like once you've got one nailed, then if you double this, you've of course got to double that one, right? So on the other side of the equal sign.
What would you do if that came up and then just, well, I don't know, say it came up to 50, but you had to come into 110?
Something wouldn't be right.
That would be right.
Something wouldn't be right. I mean, those things happen in science, but then that's when you got to go back, just like we talked about, run the sample again, and so forth. And a lot of times labs do that too. They will, I don't know if you know how it works or not, but they'll send samples to 2 different labs. Not all the time. It's very expensive to do, but if it's something extremely important, you send a lab to New Jersey, send another lab to Spokane, Washington, you get the results back. If they're the same, that's a good indication. All right. Now, if they're different, that's trouble. All right. Something's going on there. So, and you know, a lot of people think that science is this cut and dry thing. It's not. These questions like John asked, and like we were talking about with Sandy about how she tried this and couldn't make this and tried that and this and that, that's a regular occurrence. And you always have problems. That's one of the things I miss about working in a lab, is every day there's just always some kind of trouble like he's talking about. You should have gotten 55, but you got a 50. And then you got to go figure out what the hell's happening and all this drama. But anyway. Well, anybody got any questions about 7 so far? All right, well, let's meet then on Wednesday, not tomorrow, at 2 o'clock.